Good morning, everyone. Welcome to my channel, Physics Guru. In this video, I'm going to give you the exam review. So, here is the first question. We have a charge that the charge is given. The charge that is given is negative 100 microcoulomb. And then you have to find out how many more electrons that plastic object has compared with the number of protons. So what does this charge means? That's a negative 100 microcoulomb. So that means it has more electrons than the protons, and because it has a more electrons compared to the protons, it does have a negative charge. And how do we find out how many more electrons this one has? So you can use this equation n times E, where n is an integer and E is the electronic charge. And this charge here is 1.6 times 10 to the negative 19 coulomb. And from this one, you should be able to find it out the value of n. So that's the problem number 1. And I encourage all of you to write down your value, the n number, in the comment section below, and so that other students can compare each other answer. So I highly encourage all of you to do your calculation and write down in the comment section below. So let's go to the problem number 2. So we have an electric field at a distance of 5 meters from a point charge. And then you need to find out what is the charge of the object. So due to a point charge, the electric field is given by this equation kq over r square. And you need to find out the charge. So the charge will be E times r squared divided by k. And we know all the numbers here. E is given, that's the electric field, which is 200. R is also given, that is 5 meter. 5 square. K is a constant, and this constant is 9 times 10 to the 9. And if you solve, you'll get this unit in terms of coulomb. Whatever the number you will have times coulomb, that's the unit of charge. You should be able to solve it. Okay. And now we have a 5 microcoulomb is located inside a sphere. So let's call this is a sphere. And then the charge is located here. Let's call that charge is Q. And then what you have to find out, what is the electric flux due to this charge. So if you look at the electric field, if it is a positive charge, will be radiated away. So all you have to use is the Gauss law. So what does the Gauss law tell you? That the total flux enclosed by a surface is given by Q divided by epsilon naught. That's the total flux. Okay. So this sphere is including only one charge here. So the total flux passing through this sphere will be given by this equation here, Q over epsilon 0. And you know the value of Q. Q is 5 microcoulomb. And of course, you have to convert microcoulomb into coulomb. And epsilon value is 8.85 times 10 to the negative 12. I'm not writing the units here. You should be able to write down by yourself. Okay. And then you should be also find out the unit of flux as well. All right. Okay. And if you have any confusion, you can always go back to my other lecture videos and find out the units of permittivity of free space and the electric flux. So this problem here, we have 4 equal charges. So 4 equal charges here. And the side is given, the 5 meter, the side is given. Let's say one charge is here, 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 and here. And all you have to find out what is the electric potential and electric field at the center. So for electric field, you can write down, let's call this is charge Q1, Q2, Q2, Q3, and Q4. The electric potential at this point is given by, due to this charge, can be calculated by V1 is K Q1 divided by R, and R would be this distance. Okay, this distance here, that's this distance R at the center. So how do you find out this R here? You know this distance, which is 2.5 meter. This is also 2.5 meter because this is a square. So this is 2.5 meter, 2.5 meter. So this side will be, R would be given by 2.5 square plus 2.5 square. Okay, so K value, as you know that K value is 9 times 10 to the 9. I'm simply writing down the numbers here. You should be able to write down the unit by yourself. So that way you should be able to find out the potential due to one charge. Similarly, find out potential due to the second charge, third charge, and fourth charge. And you simply, the total potential will be V1 plus V2 plus V3 plus V4. Okay. So that's how you find out the potential. And now for the electric field, it is a little bit complicated because electric field is a vector quantity, so you have to think about the direction as well. So I'm going to give you an example here. So for example, now let's say due to Q1, if this is a positive charge, the electric field will be this way. Okay, and similarly due to Q2, it will be this way, and for the other charge it will be this way and this way. Okay, so all the charges, because it does say it has exactly the same charge as 10 microcoulomb, so you have to think in terms of the vectors. So one is in this way and the other will be in this direction. So what is the net? Net could be the 0. So due to these two charges, it cancels out each other, and exactly due to Q1 and Q2, it cancels out each other. So the electric field in particular case will be exactly equal to 0. But if the charges are different, or if has a different, even the signs, when I say sign, what does this mean? If one is positive and the other is negative, then you would get a certain value of the electric field, and you should be able to solve by yourself. So in all cases, I'm writing down the equation for the electric field, KQ over R squared. And remember, this is a vector quantity. All right. Potential is a scalar quantity. This is an exam review. So I'm simply giving you the idea. I'm not giving the entire solution. You should be able to solve by yourself. Okay, so here capacitors is connected in series and in parallel. So for this one, I encourage you to watch my other YouTube videos where I have talked in detail about capacitors connected in series and parallel. And the reason I mention here is because you'll have one question from this topic here. So make sure to go through this video. And again, the same thing, energy in a capacitor. You have to also study these things. Okay, and I will also share the video here. So now here about the resistivity. So you have a cylindrical wire. Let's call this is a cylindrical wire. Okay, and if you cut half, now let's say here, if you cut half, what will happen to the resistance and resistivity? So remember, R stands for the resistance, rho stands for the resistivity. That's the resistance, and that's the resistivity. And look at the relation, R equals to rho L over A. It is talking about the resistivity and resistance if you cut into half. So the resistivity is a material property. It does not depend upon the length. It doesn't matter how small you cut. Resistivity is entirely the material property, so it will not change. So rho remains constant. And now what happens to the R? If you cut in half, so if I look at the resistance of this material, what will happen to the resistance? It will also be half. So the resistance is directly proportional to the length. and inversely proportional to the cross-sectional area. The longer the length is, more will be the resistance. So that means if I cut into half, the resistance will be decreased by a factor of half. Okay. So for this problem, if the diameter of a resistor is double, what will happen to the current? So let's write down all the equations here. So we know now R equals to rho L over A. A is the cross-sectional area. So when I say cross-sectional area, what does this mean? Now let's say you have a cylinder. So this area is the cross-sectional area, and it is a circular. So what is the area of a circle? The area of a circle is pi d square over 4. So I can write down rho L pi d square, and if I use the 4, it will go on the numerator. So that's my equation for the resistance. So now look at the current. The current is V over R. So V R is 4 rho L times pi d square. Okay. So now, assuming the length does not change, what is asking here if the diameter is double. So if you look at the diameter here, what happens if you double the diameter while other parameters are constant? If you double the diameter, the current will increase by a factor of 4. Okay, it is directly proportional to I is directly proportional to d square. So the current will be a square. So now let's say if you double, then the current will go 4 times.